Assalamualaikum and hi. In this video, our group will be presenting about application of differentiation. But before we start, let's meet our members. Our members are Nurul Izzati, Siti Riana Aisyah, Raihana, and also Nur Raihan Adni.
What is differentiation? Differentiation is a method where we use to compute the rate of change of a function fx with respect to its input x. Why we use differentiation? The main reason we want to differentiate is to find the rate of change of something. If that something is the rate of change of height with distance, then we are finding the gradient. There is several techniques that we can use to do differentiation. First, we can use derivative of constant, linear and power function. Second, we can use derivative of sum and differences. Third, we can use product rule. And last but not least, we can use quotient rule. The rate of function is defined as dy over dx equals to fx equals to y. In this topic, we will learn about application of differentiation, how to solve relate rates problems, analysis of function 1, which is increasing, decreasing, and inflection points. We will also going to learn about analysis of function 2, which is extremum and critical points, first and second derivative test, graph, and maximum and minimum problems. Lastly, Rolle's theorem and mean value theorem.
In differentiation, we need to memorize the solid figure and the formula to answer the question that given. So this is the solid figure and their surface area and volume. Now, we are discussing about related rates. Related rates is a rate of change associated with two or more related quantities that are changing over time. For example, dx over dt, dy over dt, dr over dt, dh over dt, dA over dt, and dv over dt. There are 5 steps to do the related rates. First, separate the related rates. Second, fill in the blank space with the given info. Third, differentiate the formula. Fourth, substitute R using ratio. This is for cone only. And fifth, differentiate.
Let's move to the problem statement. A block of ice in the shape of cylinder has a radius of r cm and the height is 2r plus 3 cm. The ice is melting at a constant rate of 4 cm cube per second. The hint that given is V cylinder equal to pi r power of 2h. Question A. Show that the volume of ice is given by V equal to 2 pi r power of 3 plus 3 pi r power of 2. Question B. How fast is the radius changing at the instant when the radius is 2 cm?
Question A. Show that the volume of ice is given by V equals to 2 pi r cubed plus 3 pi r squared. This can be solved by applying the formula of volume of the cylinder, which is V equals 2 pi r squared h. So what we have to do is we just have to add the given radius, which is r cm, and the given height of the cylinder, which is 2r plus 3.
B. How fast is the radius changing at the instant when the radius is 2 cm? First step, we have the information that given dv over dt is negative 4 cm squared per second. So we need to find the dr over dt when radius is 2. In the first step, dr over dt, we can separate it by dr over dt times dv over dt. For the v equals to 2 pi r squared plus 3 pi r square. So the dv over dr is 6 pi r square plus 6 pi r. And then the dr over dv is 1 over 6 pi r square plus 6 pi r. And the dr over dt is 1 over 6 pi r square plus 6 pi r times negative 4. So we will get negative 4 over 6 pi r square plus 6 pi r. Given the radius is 2, so we can substitute r with 2. So the given will give negative 4 over 6 pi 2 square plus 6 pi times 2 square plus 6 pi times 2. So we will get negative 4 over 36 pi, and the last answer is negative 1 over 9 square cm per second.
In conclusion, related rates are important when we want to solve problems that are involve two or more related quantities that are changing over time. Related rates are also important because there are so many activities in our daily life that we can apply with it, like a snowball melting, a ladder falling, and a balloon being blown up. Besides that, related rates has an extensive application in physics, engineering, and other fields. Some practical application of related rates is observed the horizontal and vertical motions of space shuttles and their tracking cameras. So, this topic is very important to be properly mastered.
Lastly, before we end our video presentation, we would like to say that we are really grateful because we managed to complete this video presentation within the time given by our lecturer, Setio. This assignment is possible to be completed with the amazing cooperation and effort from our group members Raihana, Adenin, Liana, and Izati. We also would like to sincerely thank our lecturer of Calculus 1 Setio again for the guidance and willingness to help us in what we are lacking when completing this assignment and for teaching us this course. Last but not least, we would like to express our gratitude to our family members who keep on encouraging us all the time.